In this video, we're going to show that the r squared can be written as the correlation coefficient between x and y squared. And we're given the formula for the correlation coefficient right here. So the way to proceed is just to start with the formula for the r squared, which is just the explained sum of squares divided by the total sum of squares. We're going to do the population version for this. Doing the sample version is extremely similar. We just have to replace everything with hats. So remember that the explained sum of squares is just the variance of y hat, which is the variance of our explained version of y. And the total sum of squares is just the whole variance of y. And all that we have to do here is let's just plug in for what y hat is, which is just beta naught plus beta 1 x. And let's just leave the variance of y as is. So note a few things. We can distribute the variance over this, and given that beta naught is a constant, it has a variance of 0, and its covariance with any random variable, in this case x, is 0. So all that we have to remember is that we're going to have the variance of beta 1 x, and to operate over that, we can just extract the beta 1 squared, and we're going to have the variance of x. And we're going to have the variance of y in the denominator. Now let's just remember the formula for beta 1, which is just the covariance between x and y divided by the variance of x. So this is the formula for beta 1, and we have to square it. And this is going to be times the variance of x divided by the variance of y. Now all that we have to do is just distribute this square on this division, so we're going to have the covariance between x and y squared divided by the variance of x squared times the variance of x divided by the variance of y. And now note that we have the variance of x squared in the denominator and the variance of x in the numerator. We can just cross 1 with this, and we're very, very close to what we want, right? So all of this is just the covariance between x and y squared divided by the variance of x times the variance of y. And now all that we have to do is we can just rewrite this as opening a big parentheses, and we're going to have the covariance of x and y. And if we want to put the square outside of the parentheses, all that we have to do is take the square root of everything that is in the denominator, right? So it's going to have variance of x times variance of y, all square rooted. Which, if you notice, what's inside this parentheses is just the correlation coefficient between x and y that we wrote before. So this is the correlation coefficient between x and y squared.